Welcome everyone. Today we will be covering calculus, one of the most important chapters in our IGCSE Add Math syllabus. I've divided the section into two. One is for differentiation and the next one will be the integration. So let's get straight into it. First things up, we will look at what differentiation is basically. Differentiation is the process of obtaining the gradient of any function. So for example, let's take a function fx. It can be any function. And when you differentiate this to what you're basically doing is you're finding, when you're asked to find the gradient, let's say, find the gradient. The process you will be using to find this gradient is differentiation. So in general terms, we will write differentiation in this form, d over dx. So d over dx means that you're differentiating with respect to x. And this is the general equation we can have here, ax to the n plus b. So generally what you do when you differentiate any equation, so d over dx and ax to the n plus b. So what you do is you bring down the exponent of x. So whatever the exponent of x, you bring it down. And then you write the coefficient, and you need to reduce one of the exponent by 1. You need to reduce the exponent of x by 1. So n minus 1. And as you can see, d over dx of a constant, let's say b, is 0. So any constant, if you differentiate, it will always be 0. So that's why when you differentiate this plus b, you get a plus 0, which you don't usually write it. So as we saw, there are different notations for the d over dx or the differentiating notation. We also have an alternative form, which is for the functions. So let's say we had this function f of x. We write the f dash x. So this means you're differentiating with respect to x. Moreover, you can see these two. So what do these mean? This means for second derivative. So what is basically second derivative? It's nothing fancy. It's just that you're differentiating twice. You're differentiating a function twice. So when you differentiate the function twice, you put d squared y over dx squared, or in a function notation, we write it as f double dash x. Hope you understood this, and let's move on. Now you might be amused by this second derivative, and where do you actually use it? So we will be using it here to determine whether a turning point is maximum or minimum. So whenever there's a question where you need to determine a turning point, whether it is maximum or minimum, you use the second derivative test also. So it comes to play over here. So the fact over here is that at any turning point, the gradient will always be 0. So like, let's say if I'm taking a simple function as this parabola, the turning point is somewhere here. And when you draw a tangent or the gradient line, it will be 0. So the gradient of this tangent will be 0. So we will be taking this example, and let's check whether the turning point is maximum point or a minimum point. So there are two methods for this, first derivative test and second derivative test. And I will show you both. For the first derivative test, basically you do the differentiation once. So dy over dx, or let's write, because this is an fx, we will write it in the functions form. F dash x will be what you do here. So exponent of x, bring it down, 2, and you write the x and reduce the exponent by 1, power by 1. so which is 1. You don't write 1, so it's 2x. And then here you can see that 3x has an exponent of 1. The power is 1. So you bring down the power, which makes it only 3. And x to the 0 is 1, so you don't write the x here. So this is your first derivative. And now what you do is you use this fact you know and the concept of gradient we learned before. So the gradient was 0, is 0 at any turning point. So when you do differentiation, basically you're um, finding the gradient of this function. So what you do is you equate the derivative to 0. So what you get for the x coordinate over here, negative 3 over 2. So you got this right. So now what we do, we find two extremes for this, a smaller one and the bigger one. You know that this part it is 0. So at negative 3 over 2, we can take the extremes as negative 2 and negative 1. So the extremes, I'll just write it here. So you need to take two extremes. It should be a very small change, but so that you can understand where it is moving. So the extremes, let's take it as negative 2 and negative 1. So now what you do, find the gradient at negative 2 and at the point 1. So f dash negative 2 will be 2 times negative 2 plus 3. So which is negative 4 plus 3, negative 1. And then we do f dash negative 1, which is 2 times negative 1 plus 3, which is negative 2 plus 3 is 1. So the gradient at these 2 points is basically negative 1 and 1. So what you can just draw this rough sketch. So you can draw a table actually. So let me erase this. So negative 1 and 1, right? So I'll just get rid of this for once. So we got the x value as negative 3 by 2 and the f dash x is 2x plus 3, and the two extreme points, the gradient of those two extreme points we got as negative 1 and 1. You know that at turning point it will be 0, so we just draw a table like this. So this is the gradient 0, so at turning point it is 0. Let's take this as extreme 1 and extreme 2, or the other way around. So this is extreme 1 and this is extreme 2. So at extreme 1, if it is negative 1, no, actually you need to go in order. So if for negative 1 it was at negative 2, right? So this is here. So this is 1, which means you go like this. So this is negative 1, about it's going on the slanting way, and then 1 will be going towards the top like this. So when you roughly sketch this graph, it will be like this and then going upwards. So now we have the minimum, the turning point over here. So at this point, what you do, you determine this point as minimum, because you can see that this is the minimum value in this whole graph. So therefore, the turning point, the TP, turning point for TP, is at minimum. So hope you got the first derivative test. And the second derivative test is a more straightforward method than this, because here you have a long method. You need to solve for all the gradients and then check for the extremes also. So the second derivative test is basically what you do is you do f dash x first. So you get 2x plus 3, and then you differentiate it again, f double dash x. So which makes it 2. So for this there is a condition you need to remember. So the first condition here is when the f dash dash x is greater than 0, the point, the turning point is at minimum. And when the f dash dash x is less than 0, the turning point will be at maximum, is at maximum. So since here the f double dash x is 2, which is greater than 0, you can straightforwardly say by the second derivative test, the turning point is at minimum. So it's a more straightforward way. So unless you need to remember these two conditions, and then you can easily perform the second derivative test to find whether the turning point is maximum or minimum. So let's move on to trigonometric and logarithmic functions. So hope you understood this whole concept of taking the first derivative test and the second derivative test. There are some pros and cons for each. So that I think that won't be tested in your syllabus. So you just need to know both the methods so you can use it wherever you need it. So the differentiation in trigonometric and for trigonometric and logarithmic functions. So these are the basic rules you need to remember for differentiation for trigonometric and logarithmic functions. So when you differentiate sine x, you will get cos x. And when you differentiate cos x, you will get negative sine x. So just remember this negative sign. Mostly we will forget this. And when you differentiate tan x, you will get secant squared x. And then we have for logarithmic and exponential functions here. So when you differentiate e to the x, you will get the same e to the x. And when you differentiate natural log of x, this is ln x, you will get 1 over x. So these are just some basic rules you need to remember for trigonometric and logarithmic functions. Now we will have some rules or um, some rules you can need to follow for differentiating different types of equations or functions. So the first rule we will see is the chain rule. So chain rule is basically uh, here we are doing differentiating of ax to the n plus b to the k. So there are two exponents we need to consider here, this k and this n. So what you do? So I'll just explain it here. So ax to the power n plus b to the k. Sorry. So just similar as what we did for the normal differentiation, just that there's another exponent over here. There are two powers over here. So first you bring down the power of k down, and you write the equation as it is, plus b plus v. And you should not just stop here. You need to differentiate the inside function also. So this is the inside function. You have just differentiated the outside, but the inside is also having a power. So you need to differentiate that too. So you bring down the n, a to the x, and then you minus 1 from the power of the x. So this is what I've written over here, as you can see. So that's how it's done. So this is another I've just shown for the trigonometric functions. There's also a twist over here. So what you do when you have a trigonometric function of this type. When you have it in this type, a trigonometric function, like here we have sine to the n x. We can consider this to be d over dx sine x and then to the n. So there's a trigonometric function inside and a power outside. So first up, we do the same differentiation as before. We bring down the power, we write the sine x as it is, and then you reduce the power by 1 on the top. And you should not just leave here and then, but also you need to differentiate the inside function. Inside function is sine x. So what is the different derivative of sine x? Which is basically cos x. So you can rewrite this to be n to the sine n minus 1x and then cos x. So this is basically the chain rule. So you can have an exam tip here just to not forget you need to differentiate the inside function. You first differentiate the inside. So what I am telling is to first take the inside. So if I have this ax to the n plus b k, I'm telling you to first do this part. First write this differentiation and then go to the outside, because outside we generally do it, but we might forget the inside function. So that's why it's better to do from the inside to the outside. So what you do is you do the inside first, n a x to the n minus 1, and then you take the outside, k times a x to the n plus b. Yeah, so that's it. So hope you understood the chain rule. So now we have the product and the quotient rule. So the product rule is when you're multiplying any two functions and then you're differentiating it. So here you can see we have multiplied fx and gx. There are two functions, and then you need to differentiate the product of these two functions. So that this is when we use the product rule. So you can remember this easily. It's very straightforward. Remember it, remember it in words, so it will be easier. So first, what you do, first differentiate fx, and then write gx as it is. You need to write differentiate fx and then times gx. Second, differentiate gx times fx. So times fx. So first we are differentiating the fx, f dash x times gx, and then we are doing fx plus g dash x. And what you do is you just add these two values, you just add them, and then you get the derivative of the product of the fx and gx. So then we have the quotient rule. Let's move on to the quotient rule. It is similar, but it's with division. You're doing it when you're dividing two functions and then you're finding the derivative of the quotient of these two the division, then you use this quotient rule. So it's also straightforward, but you need to follow this order. So this order on the numerator is very important. So how I remember this order, first gx, first you need to do the um, differentiation of fx, then times gx minus the gx, then fx. So how I remember is first differentiate numerator. So basically the numerator over here, I'm talking about this. This is the original function. So what you do is first differentiate the numerator. So what we did here is f dash x. Then you differentiate the denominator. So then differentiate denominator. So I hope these two, it's easy to understand with words instead of just remembering the formula. So then after you do this, the denominator will be gx squared. So you just square the denominator and then you will get the denominator of the derived function. So hope you understood these two rules. And let's move on to gradients, tangents, and normal. So these are some basic rules, like facts you need to know. I hope you know this. that a tangent is always perpendicular to the normal. So whenever you draw a tangent of any curve, so let's say we draw this tangent. So the normal will be perpendicular to this tangent. So this should be 90 degrees. So with this fact, we will solve some questions. And as you can see, there's a question, example question here. Let's tackle it together. So part A, to sketch the graph. Sketch showing the points at which C meets the axis. So as you can see, this is a cubic graph, and you know the points of x-axis because it's already mentioned. So when you draw this graph, I'm just writing part A. So it should be since the x cubed will be positive. X cubed is positive. The shape would look like something like this. This is the shape of the graph. So we will draw the graph here. So it will meet at -1. Okay, so I need to extend this, or so I'll just draw the axis again. Sorry. So this should be the axis, and it will meet at -1 and -3. So it will somewhat look like this. So since it's x plus 3 squared, it will be the turning point at -3. There will be a turning point at -3. So it should be like something like this, and then the turning point. Okay, wait, okay, it should be starting from here. So it should start from here, turning point, and then move towards the positive axis. So this is how the graph should look like. So this is a rough sketch only. So they only told to sketch it, and you just write the coordinates of this y-axis, which will be 9. Because 3 squared will be 9, and 9 times 1 is 9. So that's your graph. And now we will look at, they are asking to find dy over dx, and you need to show that it's 3x squared plus 14x plus 15. So basically, first you need to just expand this. So you get x plus 1, x squared plus 6x plus 9. So part B, I'm just writing it here. So y would be x cubed plus 6x squared plus 9x plus x squared plus 6x plus 9. So when you write it in simpler terms, it will be 7x squared plus 15x plus 9. So when you differentiate this dy over dx, you bring, for first term you bring down the power 3, reduce the power of x by 1, 2, bring down the power and multiply with this, which will get 14. 2 times 7 is 14, and then reduce the power, and then this will be 15, because when you bring down the 1, it will be the same 15, and x to the power 0 is 1. And then the differentiation of this term 9 will be 0. So we have shown this. We have shown, so you can just write shown. So then part C. The point A with coordinate x coordinate -5 lies on C. Find the equation of the tangent to C at A, giving your answer in y equals to mx plus c form. So the point A with x coordinate as -5, So when you want to find the coordinates of A will be -5 and then y. So y will be equal to, you just substitute the -5 over here, -5 plus 3 squared, -5 plus 1 is -4, -5 plus 3 is -2 squared, which is 4, -16. So A has the coordinates of -5 and 16, -16, sorry, -16. So now they're asking to find the equation of the tangent. Tangent is when you find the gradient, you draw the tangent to find the gradient. So basically, they have given you the differentiated form here. From part B, you can just take it. So basically, this shows you the gradient and at A. So what you do is dy over dx at x is equal to negative. The point A with x coordinate -5 lies on C. Okay, negative. I think this is not needed actually because this is perhaps it's not needed. So we just straightly substitute this -5 into the dy over dx to find the gradient. Gradient at okay, actually we need it. Sorry, we need to find the equation also. Equation, not only the gradient. So the gradient to at A will be 3 times -5 squared plus 14 times -5 plus 15. So it's basically 20. So the dy over dx is 20. And the equation will be, you just use the y minus y1 equals to m times x minus x1 formula. So y minus y1 would be -16, which will get to minus plus 16. And then 20 times x plus 5. So then you bring this to the y equals to mx plus c form. Y plus 16, 20x plus 100, y equals to 20x plus 100 minus 16 would be 84. Yeah. So that's your answer to part C. So this is part C. So hope you understood. And now let's do part D. Part D, yeah. So I'll just write it here. Y equals to 20x plus 84. So another point B also lies on the equation C, curve C. The tangents to C at A and the B are parallel. So what does this tell you? That the gradients are equal. Gradients of A and gradient of B are equal. Find the x coordinate of B. So what's the gradient of A? We've got it as 20. So you use the 20 as it is for B too. So you can just substitute again with the formula because the formula is already given for the gradient. So dy over dx, this is part D, equals to 3x squared plus 14x plus 15. And then you just, so what you do is you substitute the dy over dx to be 20, 3x squared plus 14x plus 15, 3x squared plus 14x minus 5 equals to 0. And then when you solve it, you will get x equals to 1 by 3 and x equals to -5. So -5, x is for point A. So this is A. So definitely this is for the x coordinate of point B. So therefore x coordinate of B is equal to -1 by 3. Oh, sorry, 1 by 3. 1 by 3, not negative. 1 by 3. Yeah, I hope you got this. So you just, when you're solving questions with involving tangent and normal, you just remember the tangent is basically the gradient of any function. You use the tangent, the equation of the tangent is basically the equation of the gradient. And then the tangent is always perpendicular to the normal. A new topic here, small increments. So when you change some value of a function by very small amount, that's what is small increments here. So this is the only formula we need to know for small increments. And this symbol you might have known. This is known as delta. So delta is basically you're telling that's a small change in y with respect to a small change in x. So that's what this means. Yeah, and it's approximately to the differentiated form of any function dy over dx. So this symbol means approximate. It's approx. It's not exact. You cannot tell a small change can vary much. So since it's not varying much, we just write it in approximative form that it should be approaching dy over dx. So you can just equate it with dy over dx. So a small question here. So y is equal to tan x and use calculus to find the approximate change in y, as x increases from negative pi by 4 to h negative pi by 4 plus h, where h is small. So you can remember by this. So it's a small increment, not a large significant one. So what you do is you just first up we just do the normal dy over dx, which is going to be secant squared x, as we saw from previously. Tan x differentiated form is secant squared x, and then we equate it with a small change in y over small change in x is approximately to dy over dx. So you know that the small change in x is h. So h is the small change in x. So you can write the thing as small change in y over h is approximately to secant squared x. So the small change in y would be approximately secant squared x h times h. So that's it. So that's your answer here. So it's a small question. It's mostly this will come up like these questions only. So it should be like for three marks, 2 to 3 marks. So the last topic for differentiation and hopefully for this video is rate of change. So rate of change is basically with respect to time. So rate is basically 1/the time. So this means we are going to differentiate a quantity, any quantity, with respect to time. So that's called the rate of change. And here's a small question. So here's a small question here. So first they are asking you to show there's a figure shows a metal cube which is expanding uniformly as it is heated. After time t seconds, the length of each edge of a cube is x centimeters and the volume is v. 1 second, I'll be back. Yeah, sorry for the trouble there. So we'll just read it again. Figure 1 shows a metal cube which is expanding uniformly as it is heated. At time t seconds, the length of each edge of the cube is x centimeters, as you can see in the figure, and the volume of the cube is v. So you need to show dv over dx is 3x squared. Now you might be seeing where's the equation for v. So basically, you need to find the volume. You should know the volume of any cube is the cubed of the side cube. So the side over here is x cubed, and then when you do the dv over dx for this, v equals to x cubed, you bring down the power, you write it, reduce the power by 1. So this is what they're asking you, and it's just for 1 mark. Given that the volume increases at a constant rate of this much, 0.048 centimeters per second. So what does this show you? That the volume is changing with respect to a change in time. So that's why we are writing it as dv over dt. So dv is the small change in v with respect to the change in time. And that is equal to 0.048. So they're asking you to find dx over dt when x is equal to 8. So you might be wondering here, we have dv over dx, dv over dt, but we don't have dx over dt as an equation here. And they're asking you to find when the x is equal to 8. So how you do? First, you need to derive the dx over dt. So rule over here, there's a small equation you need to remember over here, is that dA over dB. So in general, okay, then and times dA over dB can be written as dC. Okay, so yeah, dA over dC times dC over dB. So basically, you're just splitting the dA over dB, and then you're including a dC, some other quantity, which you can use it for later. So basically, since this dC and dC can cancel each other, it's the same. So this is the formula you need to remember for these kind of questions. And here we will be doing the same. So we know dV over dx. So dx over dt is basically dx over dv times dv over dt. So you saw that change over there. So basically, you're including the volume, change in volume into the equation to derive the change in side over change in time. So now what you do is you just substitute the values. So dx over dv, we have dv over dx. So the reciprocal of the part A, dv over dx, will be dx over dv. So you will get 1 over 3x squared times 0.048. So that's your dx over dt. So now they're asking when x is equal to 8. So dx over dt when x is equal to 8 will be 1 over 3 times 8 squared times 0.048. So that should be, I believe, 8 squared times 0.048. That is about 0.00025. So that is part B. Now we will move on to part C. Find the rate of increase of the total surface area when x is equal to 8. So they're asking you to find the rate of increase of the total surface area. So for a total surface area, you know that any cube, the total surface area of any cube is x squared, and there are 6 faces, so 6x squared, or 6 times the side squared. So here it is 6x squared. The rate of increase of the total surface area. So they're asking you to find dA over, so this is part C, dA over dt. They're asking you to find this when x is equal to 8. So we use the same approach, but since at this point we have We know that dx over dt is 1 over 3x squared times 0.048, and we know dv over dx. Now again use the chain rule which we did before. dA over dB is equal to dA over dC times dC over dB. So that same applies here. You need to just add another variable. So what you do here, dA over dx times dx over dt. Okay, you can just leave it at this because you know from the back, you know that it is this. But if you're getting confused, you can just add dx over dv times dv over dt. So this is basically you are expanding it again. So then dA over dx. So you can derive it from this. So dA over dx will be the differentiation of this. So you bring down the 2, it becomes 12, and x to the power 1. And then this would be 1 over 3x squared dx over dv, and then times 0.048. So that's your dA over dt. Now when dA over dt is at x equals to 8, when it is at 12 times 8 times 1 times 3 times 8 squared times 0.048. So that should be 12 times 8 times 1 over 3 times 8 squared times 0.048. So that's 0.024. So hope you understood this part. So the only important formula at rate of change is this chain rule, which is, you just remember it here. I'll just write it once again for your note. dA over dB equals to dA over dC times dB over dC over dB. So then you can include a lot of variables in between too. So for example, you can just write dA over dB. You can derive it as dA over dC times dC over dE, let's say, times dE over dB. And then this you can just continue as and when you require the more than 3. So here we use 3 times. So yeah. So I think that's the end of today's video, differentiation. We will cover integration in the next video because I think it's taking too long. Hope you enjoyed differentiation and hope to stay in touch. If you have any doubts, you can write it in the comments below or send your doubts into the WhatsApp group. So thank you for coming.